Hi, I'm Sivan Toledo. I'm a computer scientist from Tel Aviv University, and I'll be presenting Vildehaye, a family of versatile, widely applicable, and field-proven lightweight tracking and sensing tags. This is joint work with lots of colleagues, mostly ecologists. I want to acknowledge the two group leaders among them, Allert Bijleveld from the Dutch Institute of Sea Research and Anat from the Hebrew University. Vildehaye tags have been designed primarily to be used as tracking tags for the Atlas Wildlife Radio Tracking System. They can also send the environment, altitude, and acceleration of the animal. On the right, you can see a tag bar now. The tags have been developed and used for 6 years. They've been used by 5 different research groups that operate Atlas systems in 4 countries. Other groups are currently deploying additional Atlas systems, which will also use the tags. Data collected using Vildehaye tags have been used in multiple published ecological papers, including one in Science, as well as in a few technical papers. Here are additional examples of deployed Vildehaye tags just before the animals are released, on a bat and on a songbird. Here is what Atlas tracking looks like in real time, but accelerated 100 times. The tracks are of bats living in an orchard at the end of a night. The paper focuses, of course, on the technical aspects and challenges that we faced, not on the motivation. It discusses user requirements and how users perceive and understand the design. It discusses hardware and firmware issues, and in particular, 2 power management issues with both hardware and firmware aspects. It also presents the logging and radio protocol designs. Finally, the paper discusses a few design ideas that we considered but did not adopt, as well as 3 interesting use cases. So what do users want? They want tag mass that is as low as possible to be able to tag small species and to minimize the impact on the animal. They want long tag lifespans, and they understand that this is a trade-off. They also want tags that are inexpensive and easily available, possibly with sensors and large memories, and they understand that this is another trade-off, this time between integrated tags and modular ones. Finally, they want tags to be easy to configure and program, and tags that support complex behaviors. Here are most of the hardware designs that we created, but there are a few more. You can see here both tags, boards with RF MCUs, and add-on boards with sensors, memory, or an actuator. Different design variants satisfy different needs. Many of the designs have been manufactured multiple times, as you can see in the top table. Users have configured the tags with a variety of batteries, antennas, and coatings, starting from tags that weigh less than a gram and last about 2 weeks, suitable for songbirds and small bats, through heavier tags for larger birds and bats, to tags that can last more than a year for birds of prey, or even several years for mammals like a jackal. Once a user chooses a hardware variant, he or she needs to define the tag using an existing or new tag behavior template, program the tag, solder a battery and an antenna, test the tag, code it, and sometimes add an attachment mechanism like a harness. Then put it into shipping mode until it is turned back on and deployed. Users can define templates with sophisticated behaviors. This definition, for example, defines 2 cyclic schedules, one that transmits an Atlas code every 2 seconds, and the other that also uploads data in 3 activity slots between consecutive Atlas transmissions. The definition specifies a state machine for transition between the 2 schedules, as well as the sensing schedule, which includes bursts of acceleration sensing at 25 Hz every 4 seconds, and a single air pressure and temperature measurement every 2 seconds. Going back to the user's workflow, let's look at the programming task. Interestingly, the use of a built-in serial bootloader and an FTI serial dongle with an excellent driver makes a big difference relative to the use of a JTAG dongle and associated software, which we used in earlier tags. It's not a deep issue, but it's important. The robustness and simplicity of the software matter. Let me briefly explain one of the more technical aspects of Vildehaye tags. The RF MCU that we use consumes about 16 milliamps when it transmits. The small silver oxide and lithium batteries cannot supply that much current, so the current must come from a large capacitor called a reservoir capacitor. Unfortunately, physically small, large capacitance caps are leaky. The capacitor that we use leaks 15 times or more than the RF MCU does in sleep mode. The leakage is equivalent to the average current consumption of a tag that transmits an atlas ping every 8 seconds. Therefore, to store tags with small batteries for more than a day or two, we need to put tags in so-called shipping mode, in which the capacitor and/or the battery are disconnected. Here is one solution that we use. A Hall sensor tells the MCU that there is a magnet nearby, signifying that the user wants the tag to be in shipping mode. The MCU disconnects the capacitor until the magnet is removed. The capacitor is recharged in constant current mode to limit the peak current that the tiny battery must supply. Another mechanism that we have designed and used requires no MCU intervention, only a discrete flip-flop to connect and disconnect the battery from both the capacitor and the MCU. Users can also simply disconnect one of the battery wires and reconnect to deploy, but this requires soldering and waterproofing. So this is difficult to perform in the field, especially when lots of tags are deployed. Another power management issue that we had to address is a phenomenon called concentration polarization, in which a small battery experiences a transient failure to supply power. We discovered that this is a significant cause of tag failures. Our firmware mitigates this using an ultra-low power core that is part of the RF MCU. It measures the voltage before the next transmission, and if the voltage has not recovered sufficiently, it waits for it to recover before transmitting again. Also, the Vildehaye tags that have been used so far have been used for two-dimensional tracking because the geometry of atlas systems usually does not give good altitude accuracy. But some of the tags have an air pressure altimeter on the main board or on an add-on board, and this sensor allows tracking of the altitude, and it can also make the 2D localization more accurate. Users have used altimeters in both radio upload of sensor data to a base station near the nest or via recapture of the birds. Another interesting application requested by users is to actuate a release mechanism to release a separate data logger off the leg of a crane. The Vildehaye tag waits for a radio command to release the mechanism. Once the release mechanism is actuated, the tag starts transmitting atlas pings, so that it and the logger can be found and retrieved. This has been deployed, but not yet successfully released the logger in the field. We think that the antenna that the tag uses is too small, resulting in too short a range for the radio command. We did not have time to go over all the contributions of the paper in this video. In particular, I did not talk about our energy-efficient sensor logging flash data structure, about the radio protocol, about manufacturer challenges that we faced, and about features that we evaluated but did not include in the tags, like wake-up receivers. I invite you to read about these in the paper. Vildehaye is an unusual project. It is a technology research project that provides useful tools to wildlife ecologists. Long-term support is crucial for successful tags, but is not easy to provide in a research setting. One can imagine several solutions: starting up a company or licensing the design if the market is large enough, or hoping that community support will be sufficient for an open source, open hardware project. We opted for a different solution, a long-term scientific collaboration between the technology research group, mine, and the ecology groups. This is working for us, but we do not claim that this is a universal solution. That's it. I'll be happy to answer any questions with this lovely bat carrying a Vildehaye tag in the background. Thank you very much.